Hello everyone. Today we will be talking about the relation and the functions. It's a part of mathematics, relation and functions. It's the basics of introduction to mathematics. Understanding the relation and function, the foundation of algebra, unlocking the language of mathematics through sets theories and mapping. First we have what is relation. Starting with the definition, here it's written that a set of ordered pair xy showing how elements from one set relate to elements of other. In simple words, it means let A and B a set, then relation from A to B is the subset of A into B. For example, there's one side A and the second is B. Like it's shown in the example, A is in set, it's written 1 comma 2 comma 3, and in B it's 4 comma 5 comma 6. So define a relation R, which we can see here, from A to B as R is equal to 1 comma 4, 2 comma 5 and 3 comma 6. This means that 1 is related to 4, 2 is related to 5 and 3 is related to 6. And some additional information about relation is like every subset of R is a relation where R is equal to A into B. Now moving to the next slide, we have domain and range. This is the most important part of relation and functions. So domain means the input, what we are giving. So its definition is the set of all first elements. Like you can see here, A. It's talking about A. First elements means X, where it's written A. In ordered pair, there are the possible inputs for the relation. For example, 1 comma 2 2 3 comma 5 3 comma 4 1 comma. The domain is 1 comma 3. Range means the output, that sets of all second element y in the ordered pair. These are resulting the outputs. For example, here you can see that A, it's written A, B, C and D, and in B it's P, Q and R. Will be considered as domain and B will be considered as range. So moving to the next slide, we have functions. So the first, starting with the definition of functions, we have learned like about the relation. Now it's the time for function. A function is a function means let A and B be a non-empty set. A function f from A belonging to B is an assignment of each element of A to exactly one element of B. Means if A, there is a set of A, B, C, and second there is D, E, F, like it's shown here. So it's not a function because there are three fundamentals of it. So f A is equal to B, function A is equal to B, where B is the a set of only element of set B assigned by the function f to the element A belongs to A. Every element of A should have a image in B, but B need not have pre-image of all its element. Like here it has pre-images of it, and here A belongs to D, B to D and C to F. Like every function is covered in the domain. Same goes with this example. So this both will be considered at function, but this is not because it don't justify both the conditions. Like you can see here the examples. If f A belongs to B such that fx is equal to x square, where A is equal to 1 comma 2 comma 3 and B is equal to 1 comma 4 comma 9 comma 16 comma 20, it all have their images in B. So this is known as the function. And moving to the next, the difference between relation and function. Relation allow for only one to many correspondence. A single output can be paired with multiple distinct output, but and functions must maintain one-to-one or many-to-one corresponding. Each input is restricted to exactly one output. So this is the only difference between relation and function. Okay, so moving to the next, the type of functions. So in types of function, first we have one-to-one injective. One-to-one functions is also known as injective functions, means that every pre-image has a unique and a different image. For example, we can take previous example this one. We can take previous example this one means A should have only image with D, B should be go with E, and C should be go with F. G should not be there, but here it has. So this will be considered as one to one. Means every pre-image has a unique and a different image. Basically, one element is connected to another. This is in simple words we can say that basic one element is connected to only one, not many one. Moving to the next, we have onto means surjective functions. In onto function, every image should have one pre-image. Like every image should have one pre-image. It is also known as surjective function. Bijective means one to one and onto means it should satisfy both the condition. It should be one to one also, it should be onto. The perfect pairing the function is both injective and surjective, establishing a precise correspondence between sets. Moving to the next slide, we have taken an example. Check whether the following function is one or onto. We have taken f a to b, fx is equal to x plus 1, where a is a set where it contains minus 1, 0, 1, 2, 3. B we have 0, 1, 2, 3, 4. So it is like a one-to-one function because both the functions have one-to-one and on-to-one. All pre-images have an unique images and every image has a pre-image. You can see this example. And second one is like check if the given function f r is tends to r is one to one or onto such that fx is equal to 2x plus 3. Given is equal to fx is equal to 2x plus 3, we have to prove it's a 1 1. Let take x comma y is the element of r. So fx is equal to fy, where fx we can take is 2x plus 3 is equal to 2y plus 3. So it has x is equal to x, y, where it means that it is only one to one function, means one is connected to only one, not many. Moving to the next, we can take the real world examples of mapping concepts. Real relation in practice. Student of courses, a single student is enrolled in multiple courses which will be considered at one to many. Person to hobbies, one person enjoys several different hobbies. Customer to purchases, a single customer make a variety of different purchases over time. Function in practice, employee ID to SSN. Each employee ID corresponds to exactly one security number. Time to temperature, at a given moment in time the temperature is single specific value. Product SQS to price. Now moving to the next one, why relation and function matter. This is our final slide. So foundation of calculus, function are the central object of study in calculus, essential for understanding the rate and changes accumulation, real world monitoring, predictable mapping and programming and logic. So this was our relation and function. Thank you so much.